Hello, everyone, and welcome back to the deep dive. Today we're completely shifting gears.
We really are. We're getting into the weeds today.
Yeah, exactly. We are rolling up our sleeves, putting on our reading glasses, and getting incredibly technical. We are tackling the absolute beast that is the 2V0-18.25 exam.
The VMware vSphere Foundation exam. It's definitely a hurdle for a lot of folks.
Right. And if you are listening to this right now, you probably already know that this isn't just about, memorizing where a specific button is on a dashboard. It is really about understanding the underlying logic of IT architectures and the VMware Cloud Foundation.
Yeah, I mean, a lot of people approach these certification exams thinking it's purely a memory game, like flashcards. They try to just memorize the what. But with VVF, it's so much more about understanding the relationships between the components.
Well, dependencies.
Exactly, the dependencies. If you understand why the system works the way it does, then the actual answer on the test just becomes obvious.
Which brings us to our specific mission for today's session. We've got a stack of source material here. Specifically exam prep notes, actual practice questions, and the detailed explanations behind the answers.
The good stuff.
The really good stuff. So we are going to treat this strictly as a dedicated study session for you. We're going to strip away the jargon and look at 10 specific practice scenarios to see exactly why the correct answer is, well, correct.
And perhaps more importantly, why the wrong answers are wrong.
No.
Because in these multiple choice gauntlets, understanding the distractors, those trap options, is usually where the actual learning happens.
100%. So just a quick roadmap for you listening. We are covering the big 5 sections of the exam today. That's IT architectures, VCF fundamentals, planning and designing, building and operating, and finally, support.
It sounds like a full plate.
Oh, it is. So I am ready to quiz you if you are ready to explain the why behind the what.
Let's do it. I'm ready. Let's dive right in.
Okay, awesome. Let's unpack this first section. We are calling this the storage and connectivity gauntlet. Scenario number 1. Picture this. You're an administrator, and you are trying to migrate a virtual machine using vMotion.
Standard day-to-day stuff.
Right, something you literally do every day. But this time it fails, and the error message basically says the destination host cannot access the shared storage.
A classic headache right
It
there.
really is. So the pressure is on, your migration is failing. What is the very first thing you verify? The source material gives us 4 options. Is it the hardware version of the VM, the number snapshots, the memory reservation, or is it the storage presentation and masking on the physical array?
Well, before we jump to the answer, what's your instinct here?
Honestly, I feel like snapshots is a huge trap answer here because snapshots break things all the time.
They do. They really do. And that is exactly why it is a distractor on the exam. Snapshots can totally cause performance issues or timeouts during a live migration, but look closely at the specific error in the scenario. Cannot access shared storage.
Okay, so it's a visibility thing.
Exactly. This is a visibility problem, not a performance problem. For a live vMotion to work, the source host, where the VM currently lives, and the destination host, where you want it to end up, they have to be looking at the exact same map.
They need to see the same data store.
Right. They need the same data store ID. So the answer here has to be focus on the storage presentation and masking on the physical array.
So just to clarify for the listener, what does masking actually mean in this specific context?
Think of the physical storage array as a secure office building. LUN masking and zoning are essentially the security badge access system.
Okay, I like that.
If the zoning on your fiber channel switch or the LUN masking on the array itself is misconfigured for that specific destination host, it's like the host is completely blindfolded. It literally cannot see the storage device.
It doesn't even know the building exists.
Precisely. And if it can't see the building, it really doesn't matter if the VM inside has 50 snapshots or what VM hardware version it's running, or if it has giant memory reservations.
Because the host can't even see the floor the VM is supposed to land on.
Exactly. Hardware versions and memory reservations are attributes of the VM itself. They're the furniture inside the house. Masking determines if the house actually exists on that host's map.
Got it. Okay, so rule out the VM level stuff and look at the physical connectivity first. That makes total sense. Let's move to scenario 2. This one is all about the vSAN health service.
The watchdog.
Yep, the watchdog for your storage cluster. The question asks what exactly the vSAN health service monitors to keep the cluster safe. And we need to select 2 things here from the options. Is it the guest OS patch level, physical disk drive health, VM hardware version, or network connectivity between storage nodes?
This actually connects right back to that distinction between infrastructure and furniture we were just talking about. The correct answers here are physical disk drive health and network connectivity between storage nodes.
Okay, but again, playing devil's advocate for a second, why wouldn't it care about the guest OS patch level? I mean, isn't security a massive part of the overall health of the system?
It is part of the environment's health, absolutely. But it is not part of the vSAN health. You have to step back and remember what vSAN fundamentally is. It is a distributed storage system. Its entire job is the plumbing.
Right.
It cares about the integrity of the actual data blocks, so it urgently needs to know, hey, is this physical disk about to fail? Because a failing disk endangers the data directly. And it needs to know, can these physical hosts talk to each other?
Because if they can't talk, they can't sync.
Exactly. vSAN relies entirely on the management and vSAN network to synchronize objects across the cluster. If that network drops, your data becomes inconsistent across the nodes.
Whereas a missing Windows security update inside a random virtual machine
Is totally a problem for the Windows application admin, but it absolutely does not threaten the structural integrity of the vSAN data store itself.
So basically, if you are sitting in the exam room and you see guest OS, anything in a vSAN health question, you can pretty much cross it off immediately.
Pretty much. vSAN looks at the foundation of the house, not the curtains in the living room.
Love that analogy. Okay, let's move into part 2 of our deep dive here. Maintenance and performance troubleshooting. This is where things get really real for administrators because now we are dealing with keeping the lights on.
The day-to-day operations, the stressful stuff.
Seriously. Okay, scenario 3. You need to do hardware maintenance on a vSAN host. Let's say you're replacing a faulty fan or maybe adding some more RAM. You need to put this host into maintenance mode. How do you ensure full redundancy during that maintenance window?
Important question.
Very. The options are ensure accessibility, no data migration, or full data evacuation.
The absolute key words here, the ones you have to highlight in your mind, are full redundancy. That changes the entire calculation. The answer has to be full data evacuation.
Now, I can already hear some of our listeners yelling at their speakers, but wait, full data evacuation takes forever. Doesn't that move potentially terabytes of data across the network?
Oh, it absolutely does. It takes a long time. It is the heavy lifting option. It basically empties the host completely before it lets it shut down. But you have to look at the strict requirement in the scenario. The prompt said, ensure full redundancy.
Okay, so what happens if you choose one of the others, like ensure accessibility?
If you choose ensure accessibility, vSAN just does the bare minimum. It makes sure the virtual machine data is readable on other hosts, but it doesn't rebuild the mirrored copies. You might be running on a single copy of that data.
So if another drive on a completely different host fails while I'm swapping out that fan?
You lose data. You are flying without a net. You do not have redundancy during that window. Full data evacuation forces vSAN to move everything off that host so that every single object still has its full mirror or RAID parity securely placed elsewhere in the cluster.
Okay, wow. So what about no data migration? Is that basically just gambling?
No data migration is literally saying, I hope to God nothing else breaks in the next hour. It leaves the data right there on the host you're taking offline. If the cluster suddenly needs to read or write that specific data, it has to look elsewhere. And if that elsewhere has an issue, you are in deep trouble. For full guaranteed safety, you just have to pay the time penalty and evacuate everything.
Good to know. Don't cut corners on the exam. All right, scenario 4. This one definitely hits close to home for anyone who has ever worked a support desk. A user calls up complaining their VM is super sluggish. It's just slow today, they say.
The classic ticket.
The classic ticket. So you investigate and you find a bunch of old snapshots attached to the VM. What is the actual fix here? Do you create a new snapshot to baseline it? Do you increase the disk size? Or do you delete and consolidate the existing snapshots?
The answer is absolutely to delete or consolidate the existing snapshots, and I cannot stress enough how huge this is for performance troubleshooting.
But why do snapshots kill performance so badly? I feel like a lot of people view them as a backup strategy, like, oh, I have 10 snapshots from the last 10 days, I'm super safe.
That is such a dangerous misconception in VMware environments.
Yeah.
A snapshot is not a backup. It is a freeze frame. When you take a snapshot, the original base virtual disk becomes strictly read-only. VMware then creates what's called a delta disk. It's a little side file where all the new incoming changes are written.
Okay, I follow you.
So if you keep that snapshot around for months, or worse, if you stack snapshots on top of snapshots on top of snapshots, the system has to traverse this incredibly long chain of delta files every single time it wants to read a piece of data.
Because it has to figure out which file has the most recent version of that data block.
Exactly. It has to check Delta 3, then if it's not there, it checks Delta 2, then Delta 1, and finally the base disk. That increases your disk I/O overhead and your storage latency massively.
So it's kind of like trying to read a textbook, but every single page has 10 sticky notes on it with corrections, and you have to read every single sticky note to understand the actual sentence.
That is a perfect analogy.
Yeah.
That's exactly what the hypervisor is doing. So the fix isn't to give the VM more storage space or to storage vMotion it to a faster flash array that doesn't solve the broken chain issue. You have to consolidate.
Which means
Telling vSphere to merge all those sticky note changes back into the base disk and then delete the chain entirely.
cleaning up the mess.
Exactly. In virtualization, hygiene is performance.
Hygiene is performance. Put that on a t-shirt.
Oh.
All right, let's shift gears to part 3. We are moving into configuration, automation, and intelligence. We're talking about VCF Operations, what a lot of folks still call VROps, and we're talking about DRS.
The brains of the operation.
Scenario 5. We are trying to cook up an alert definition in VCF Operations. What 2 exact ingredients do we need to actually trigger a notification? The source material gives us options like symptom definition, historical report, assigned recommendation, and risk analysis.
To define an actionable alert, you need 2 core things from that list: a symptom definition and an assigned recommendation.
Walk us through the underlying logic there. Why wouldn't a historical report be part of an alert?
Think about it like going to a doctor. You need a symptom. Say, the patient's temperature is over 100 degrees. That is the trigger. That is the mathematical condition being met. But an alert inside an enterprise system isn't really useful if it just runs around screaming fire.
Right, you need to know what to do about the fire.
Exactly. You also need the recommendation. Take 2 aspirin and rest. So VCF Operations pairs the what is wrong, the symptom, with the what should you do about it, the recommendation. Things like historical trend reports or risk analysis dashboards, those are informational. They are super valuable, but they don't dynamically trigger an alert.
It's the difference between watching a weather report on the news and hearing a tornado siren outside your window.
That's spot on. One is analysis, the other is a direct action signal.
Okay, moving on to scenario 6. We have a cluster. DRS, Distributed Resource Scheduler, is enabled. But you look at the cluster and the compute load is still totally uneven. One host is absolutely sweating, CPU pegged, and the other host is practically bored. How do we force DRS to balance this better? Do we mess with admission control? Or is it something else?
The answer is to adjust the migration threshold.
See, here's where it gets really interesting for me, because understanding the precise difference between admission control and migration threshold is tricky. I feel like admission control is the trap answer here for people who are rushing the exam.
It is a very common mix-up. People see control and think it controls the balancing, but admission control is really about asking, can I fit in the club? It ensures you have enough spare, untouched capacity in the cluster for HA failover.
High availability. So if a host dies, VMs have room to restart.
Right. It stops you from powering on too many VMs in the first place. It's a strict gatekeeper.
Yeah.
But it does absolutely nothing to balance the load of the VMs that are already running.
Okay, so admission control is the bouncer at the door of the club.
Yes. The migration threshold, on the other hand, is like setting the sensitivity dial on your home thermostat. If you set the threshold to be very conservative, a low-number DRS is lazy. It only moves a VM if the imbalance is disastrously huge.
But doesn't want to cause disruption.
Right, because vMotion has a tiny performance cost. But if you raise that threshold, if you make it more aggressive, DRS becomes a total perfectionist. It will actively move VMs around for even a tiny fractional improvement in cluster balance.
So if your cluster is lopsided, your thermostat is just set too low. You need to dial up that migration threshold to tell DRS, hey, stop being lazy, be more proactive.
Precisely. You just have to be careful not to make it too aggressive, or you'll end up with VMs bouncing back and forth, constantly trying to find perfect balance. We call that VM Pong, and that causes its own massive performance hit.
VM Pong. Sounds like a terrible arcade game. All right, we are entering part 4. Now, this is a special section. We are looking at the really deep technical concepts. And I want to point something out to you, our listener here. In our source material for these next few points, the actual practice questions provided were a little mismatched with the answers.
Yeah, that happens sometimes in prep notes.
It does. But the explanations underneath them contained absolute pure gold. So we are going to extract those knowledge nuggets directly because they are highly testable concepts.
This is often where the real value lies anyway, in the detailed architectural reasoning provided in the answer keys.
Exactly. So concept one comes from a discussion on storage failures. We are talking about specific severe disasters, permanent device loss, which is PDL, or all paths down APD.
The true nightmare scenarios for a storage admin.
The source highlights a feature called VM Component Protection, or VMCP. What is the big takeaway here? Why do we even need VMCP if we already have regular high availability turned on?
The real insight here is about how vSphere HA has evolved over the years. Originally, standard HA just restarted VMs if a physical host completely died, like if someone pulled the power plug.
Yeah.
But what if the host is perfectly fine, the CPU's humming along, but the storage underneath it just vanishes?
That's your PDL or APD state.
Exactly. The host is alive, but the VM can't reach its disk. So the VM technically stays running in memory, but it can't read or write a single thing.
It becomes a zombie.
A total zombie. It
Yep.
just freezes. The guest OS inside might blue screen, or it might just hang indefinitely waiting for an I/O response that is never coming. VMCP is the specific policy engine within HA that detects these weird storage states.
So it's not about buying backup hardware. It's about the software being smart enough to know what to do when the drive vanishes out from under it.
Exactly. It detects the nuance. PDL means the storage array is actively sending a code saying, hey, this device is gone forever, stop trying. EPD means the host is saying, I can't talk to the storage right now. The switch might be rebooting, but it might come back.
So you need different rules for those two events.
Right. VMCP allows you to set granular rules, like if it's a PDL, kill the VM instantly and restart it elsewhere. But if it's APD, wait 3 minutes and see if the path comes back before you take drastic action. It actively prevents VMs from freezing in that zombie state.
Zombie VMs are never good. Okay, concept two, vCenter backup mechanics. I feel like enterprise IT people overcomplicate this constantly. They assume they need a dedicated, expensive enterprise backup server.
Oh, all the time.
Right.
And the source material clarifies this beautifully for the exam. To successfully back up the vCenter server appliance, the VCSA, you absolutely do not need a specific backup server license, and you don't need to install a third-party agent inside the appliance.
So what do you actually need?
A supported network protocol. That is literally it. FTP, FTPS, SCP, HTTP, or HTTPS.
So just basic file share.
Basically, yeah. The VCSA has a native built-in backup scheduler. You just open the management interface, point it at a URL, like an internal FTP site, give it some basic credentials, and it streams the file-based backup directly there. It is incredibly simple, but people taking the exam often look for a much more complex, expensive-sounding solution that just doesn't exist.
Keep it simple. Don't overthink it on the test. I like it.
Mm.
Concept three, network traffic hygiene. The source talks heavily about separating management traffic, vMotion traffic, and storage traffic.
This is a really critical security and performance concept in VCF. We talk all the time about VLAN's virtual separation, but the source material specifically emphasizes that for true guaranteed isolation, you need separate physical network adapters.
Why aren't VLANs enough? Doesn't tagging a VLAN separate the broadcast domains?
Logically, yes. VLANs segregate the packets logically so they can't talk to each other, but they still have to travel down the exact same physical pipe. Think of it like a highway. VLANs are just the painted lines on the road. But if your vMotion traffic suddenly spikes, say you put 3 hosts into maintenance mode and you're migrating 100 VMs at once, that traffic will saturate the physical cable. Your management traffic might get completely choked out, even if they are technically on different VLANs.
It's like painting lanes on a highway. It organizes the cars nicely, but if there's a massive traffic jam in the vMotion lane, the management cars are still stuck behind the same physical bottleneck.
Perfect analogy. Separate physical adapters mean you are building a completely separate highway. That way, a massive vMotion event or a storage burst cannot possibly impact your ability to ping or log in to the management interface of the host.
Got it. Hardware isolation is the gold standard. Finally, concept 4, memory stress signals. The source explanation dives into something called a high memory swap-in rate. What exactly does this signal to an administrator?
This is the red flag of all red flags. If you are looking at Xstop or VCF Operations and you see a high swap-in rate, it means your host has completely run out of physical RAM.
Unpack that a bit for us. What is actually happening physically inside the box?
When ESX is under memory pressure, it is smart. It tries a bunch of other lightweight techniques first, things like memory ballooning or memory compression, to dynamically squeeze more VMs onto the host. Swapping to the physical disk is its absolute last resort.
Because it's desperate.
Very desperate. It means the host forcibly took a chunk of a virtual machine's active memory and wrote it to the physical hard drive just to free up space in the RAM. That action is called a swap out.
Okay, so that is swap out. Then what is swap in?
Swap in is when the penalty comes due. It means the VM suddenly needs to access that specific data again. But the data isn't in RAM anymore, so the hypervisor has to pause the VM, go down to the incredibly slow hard drive, read the data, and swap it back into the fast RAM.
Which causes a massive performance stutter.
Massive. Because a physical disk, even a fast NVMe drive, is still thousands of times slower than DDR RAM. It causes horrible latency.
So seeing a high swap-in rate confirms that the host was recently under severe memory overcommitment pressure. It's not a network issue, it's not a CPU issue, it is a strict capacity issue. You are out of RAM.
Exactly. It's a crucial distinction. It's not just that the host is working hard.
Right.
It's that it has physically run out of room and is using the storage disk as a very, very slow crutch.
All right, well, that is a wrap for this deep dive. Take these nuggets, visualize the architecture, remember the dependencies, and go absolutely crush that exam.
Good luck, everyone. You've totally got this.
See you next time.